The render network is fostering a decentralized ecosystem for 3D digital assets, transforming how digital content is created, shared, and monetized. As digital interactions grow deeper, including mobile media and augmented realities, content creators face increasing complexity. There is a rising demand for large-scale computational tasks, including rendering and machine learning, requiring innovative solutions for efficient content exchange. The render network is designed to meet these needs through a blockchain-based peer-to-peer platform, ensuring secure writes and swift processing of tasks. As immersive computing technology advances, the render network is essential in making production tools accessible. It addresses the need for a decentralized rendering system that supports next-generation media, including holographic content and AI creations. This platform utilizes GPU resources to generate high-quality 3D content, efficiently processing millions of frames annually for films, television, stadium graphics, and popular NFT collections. The current demand for computational power exceeds the capabilities of centralized GPU clouds, creating competition for resources that drives up costs for artists. New augmented and mixed reality content exacerbates these limitations, making it challenging for creators to produce immersive experiences. Many GPUs remain unused when not actively rendering, while cryptocurrency mining consumes resources inefficiently. The render network connects creators needing computational power with those possessing idle GPU resources, enhancing productivity. It simplifies the process of rendering and streaming intricate virtual content through a peer-to-peer network. Node operators can earn RNDR tokens by contributing their unused GPU power to the network, which also facilitates a marketplace for funding various digital projects. This network serves a broad audience including artists, engineers, and developers, enabling efficient production across various fields. Independent creators can access on-demand GPU resources without the heavy costs of traditional infrastructure. Applications range from 3D visual effects to creating NFTs, where artists can tokenize interactive virtual assets. The render network also supports advanced use cases like virtual production in filmmaking, large-scale projections for events, and architectural visualizations. Researchers can run complex simulations, and engineers can create hyper-realistic content for training. It enables the development of augmented reality experiences and AI applications, leveraging the network's capabilities while ensuring digital rights management. The architecture of the render network consists of two main layers: an off-chain rendering network involving creators and node operators, and a blockchain layer managing payments and contracts. Together, these components strengthen the ecosystem, providing the necessary infrastructure for the evolving landscape of digital content creation and consumption. By utilizing the public ledgers of blockchains, interactions between creator and node operators are transparent and verifiable. This allows creators, node operators, and the foundation team to confirm the accuracy of all transactions, making any discrepancies easy to track and rectify. Node operators and creators engage in a distributed network model supported by a core infrastructure of servers. OctaneBench is a proprietary benchmarking tool, widely recognized in GPU rendering, that measures GPU performance in OctaneBench points per hour, impacting rendering task pricing. This ensures creators face consistent performance-based pricing when requesting services from node operators, with costs assigned through a multi-tier pricing algorithm. Reputation scoring is pivotal, as it establishes trust for node operators who complete jobs effectively and promptly. Creators also build reputation by successfully using the network, allowing them to access more concurrent GPU nodes over time. This system reduces congestion and mitigates risks from failed renders or malicious attacks. The reputation scoring is regularly updated to improve network efficiency as tasks and services evolve. Resource allocation on the render network includes job allocation and node allocation. Job allocation assigns a creator's scenes to nodes, prioritizing based on the creator's reputation score, scene size, and available nodes. Higher reputation scores allow creators to run more jobs concurrently and make their tasks more attractive to nodes. Node allocation assigns rendering tasks to node operators based on tier selection, hardware requirements, user reputation, and performance scores. Privacy and security are paramount for users ranging from individual artists to large studios. The network employs end-to-end encryption, hashing, and secure storage to protect creator privacy. Scenes are divided into assets that are hashed and encrypted during upload, and rendered outputs are encrypted before transmission. Each frame is watermarked prior to download, ensuring payment before access. The render network features an API for developing third-party applications, supporting customizable rendering pipelines and microservices. It also includes an SDK for software integration. The network utilizes the open ORBX file format for distributed rendering, capturing scene data and enabling streaming. ORBX is compatible with various digital content creation tools and facilitates efficient rendering across the network. New third-party render engines like Maxon's Redshift and others are being integrated, with artists likely facing license fees for these engines. KY waives fees for Octane Render. With the rise of AI, the render network can accommodate heavy computational demands for tasks like neural reflectance field rendering and generative AI processes, leveraging its decentralized GPU resources. 3D artists are increasingly incorporating AI-generated content into their workflows, blending traditional digital artistry with generative AI tools. The render network supports this integration with resources like Stable Diffusion, allowing artists to create high-resolution immersive 3D environments and generate various assets. The network enables frictionless distribution of large-scale AI art collections and emphasizes the need for digital traceability and asset verification through detailed on-chain provenance. AI technology also enhances the rendering process on the render network. The Octane Render engine employs AI denoising that optimizes rendering for complex scenes, improving efficiency and speed. These AI models are trained to maximize performance, addressing limitations related to VRAM capacity. Each component of the render network, including uploaded ORBX files and render jobs, is hashed, ensuring traceability and the ability to mint NFTs based on this data. This process tracks scene changes over time, facilitating the emergence of dynamic and interactive art. The network also provides GPU streaming experiences, allowing ultra-high-resolution media to be distributed and consumed directly through browsers without additional hardware. The X.io GPU application aids in this process, catering to user needs for scalable 3D services that can be monetized. To enhance flexibility, the multi-tier pricing model offers creators various pricing options based on their needs for speed, cost, and security. Tiered services, ranging from access to high-priority GPUs in Tier 1 to more economical options in Tier 3, provide users with adaptable choices. This structure can evolve based on demand. The burn and mint equilibrium model, established by community vote, governs network operations. It allows for predictable pricing in fiat while facilitating RNDR transactions. A portion of the fees collected is used to purchase RNDR, which is then burned to maintain economic balance. Emissions are structured to encourage participation from creators, node operators, and liquidity providers, ensuring sufficient liquidity for RNDR transactions. Emissions are regulated to reflect network growth and need, rewarding users based on their activities within each epoch, typically 24 hours long. This can include returning a percentage of RNDR spent back to creators and providing distinct rewards for node operators and liquidity providers. Moreover, the net emissions cap will allow the recycling of burned RNDR to continue rewarding contributors even after the maximum supply cap has been reached. The implementation of this balanced ecosystem integrates the network's key stakeholders, ensuring sustainable operations while promoting engagement and growth. The job to be done involves providing rendering power for creators through the render network. The creator seeks rendering services, while the nodes process these tasks. Transactions are recorded on-chain using RNDR tokens, with jobs priced in fiat but payable in fiat or RNDR. Upon job approval, the protocol burns the necessary RNDR based on current market rates, documenting the transaction publicly. If a creator pays with RNDR, the amount burned reflects the rate at the transaction time, not the completion. A render network creator may burn $5 of RNDR to generate $5 worth of non-fungible job credits, which track job completion. Node operators earn RNDR through two main categories of rewards. The first includes availability incentives to show readiness for work. The second rewards those who complete jobs submitted to the network. For example, if 2% of RNDR burned during a period is attributed to a node operator, they receive 2% of emissions for job completion. If the node operator maintains 5% uptime during reliability checks, they earn an additional 5% for availability. The render network imposes a 5% network fee on transactions to cover operational costs. RNDR was first created on the Ethereum blockchain in 2018, migrating to a new contract with a reduced supply of 536 million RNDR tokens. The community sanctioned RNP001 in January 2023, which introduced a 20% inflation pool for incentivizing network participants. RNDR supply will increase by over 107 million across 2 phases, with the total capped at 644 million. The supply grows in small batches and adjusts to burning activities, emphasizing a front-loaded reward structure in the initial years, decreasing thereafter. RNP governance manages any schedule modifications, with future expansions outlined for the Solana blockchain. Reputation systems within the network document task performance, allowing creators to review results and influence node operators' reputations dynamically. Improved order matching integrates node history and capacity, promoting fair compensation and network competitiveness. The billing model may evolve to accommodate time-based rentals, while a dispute resolution process addresses subpar work by node operators. Governance for the network is maintained by the Render Network Foundation, a nonprofit that oversees protocol improvements and community engagement. Changes to the network follow a structured proposal process, guiding ideas from initial concept to implementation.